Hey guys, how do you add and subtract radicals from each other? Well, first you have to simplify them, and then you can combine the ones where the radicands match. The radicands are the numbers underneath the square root. And the radicands here don't match for any of them, but once I simplify them, some of them will. Let's do that first, then I'll show you which ones we combine and how. The square root of 12 is not a nice number, but the square root of 4 is. So I can rewrite root 12 as root 4 times root 3. See how 4 times 3 is 12? You break it up and you rewrite it like that. Now I'm going to keep going here so you can see how I'm simplifying. Root 4 is 2, and the square root of 3, you can't do anything with it, so I'm going to leave it there. Now what's the square root of 24? Well, I don't know, it's not a nice round number, but the square root of 4 is. So I'm going to rewrite this as the square root of 4 times the square root of 6. The square root of 6 isn't a nice number either, and it can't even be broken down into a smaller number that does have a perfect square. So I end up with 2 root 6 here. I'm going to keep switching colors just for your visual pleasure here. The square root of 75 is not a nice round number, but the square root of 25 is. So I'm going to rewrite it as the square root of 25 times the square root of 3, because it's 3 times 25 to make 75. That's minus 5 for the square root of 25, and the root 3 is left over. I got my coefficient, I got my radical symbol here, and I got my radicand. These root 3's will be combined later, but I'm getting ahead of myself. Let's just keep on going here. Root 27, not a nice number, but the root of 9 is. So that's the square root of 9 times the square root of 3. That's 3, root 3, because the square root of 9 gives me that 3. And 150 isn't a nice round number either. I could probably divide that by 25. 150 is 25 times 6. So this is 5 root 6. Look at that, 5 quick simplifications. Now to add and subtract these, I can only combine the things where the radicands or the number underneath the square roots match. So what can I collect here? This 2 root 3 minus 5 root 3 plus 3 root 3. I can combine those because there are root 3's in every single case. Now what I'm actually going to do is take the whole numbers and combine those with addition or subtraction. Just like if this was 2x minus 5x plus 3x, I'm going to add these in the same way. The x doesn't change, the root 3 doesn't change, the numbers are combining. 2 minus 5 is negative 3, plus 3 is 0. Ah, crap. Well, that just cancels out. I could write 0 root 3, but nobody would do that. 0 times anything is 0. I can't believe those canceled. Not my best example, but whatever. And finally, I can combine my root 6's. I've got 2 root 6 here, plus 5 root 6. I can combine them because the root 6's match, and 2 plus 5 is 7. Root 6. Dunzo! Addition and subtraction of radicals is easy as long as you have them fully simplified and you keep them separate and distinct until the time comes when you can actually combine them. And you combine ones where the radicands match, that's 3, 3, 3. 2 minus 5 plus 3 canceled out. 2 and 5 for the root 6's made 7 root 6, and I'm done. Can you believe that this whole thing simplifies to just 7 root 6? Well, your calculator knows that, and now you do too. Hey, best of luck to you.